Hi everyone. I wanted to look today specifically at questions on the review packet that are going to be on the final exam, the type of questions that you'll see on the final. Because I've already said that specifically we're looking at congruent triangle stuff and parallel and perpendicular lines and getting equations of those. So first off, you should know what parallel and perpendicular are. You should know that this sign means parallel, and this sign means perpendicular. And parallel lines don't intersect. Perpendicular lines, when they cross, they make right angles. And so you should know those definitions, you should know those symbols, so that when you see them, you can associate those with parallel and perpendicular. And you should associate with parallel with not intersecting, perpendicular, right angles. Okay, we've talked a lot about that. The other thing you should associate with these is that parallel lines, when we talk about these slope-intercept form equations and graphing these, parallel lines are going to have the same slope. And perpendicular lines, the slopes are going to be opposite reciprocals. And so when we go through and look at the equations of the lines, we should focus in looking on the slope and seeing what kind of slope we have. So on this one, when it says tell whether the lines are parallel or perpendicular or neither, we are going to focus in on the slopes. So the slope of this line, here is 3/4. It's the number that's attached to the x. 3/4. That's one of my lines. That's my red line. For my blue line, I'm going to put it in blue. My blue line, I can't tell the slope yet because it is not in slope-intercept form. Or in other words, y is not by itself. So I don't know the slope yet. So I actually need to set this up and solve it for y. So I want to get everything except for y on the other side. So I'm going to subtract the 4x so that it cancels out on that side and moves to the other side. So I just have a 3y now. So get rid of our multiplying by dividing by 3. We're going to divide by 3 on both sides. And remember, when we divide an equation like this, we're going to divide everything in the equation by 3. So we're going to take that negative 4x, and we're going to divide it by 3. So 3 goes on the bottom there. And then we're going to take our 6, and it divides by 3. But the thing we want to focus on is our slope here. Now that y is by itself, our slope is our number that's attached to the x, so negative 4/3. And based on these two slopes, since my original slope was 3/4 for the red line, I'm looking for the blue line. If we're parallel, then I'm looking for it to match. I'm looking for it to also be 3/4. If I want it to be perpendicular, I want it to be the opposite reciprocal of 3/4. Opposite change the sign, reciprocal flip the fraction. If I'm looking for neither, I would have any other number. So I'm focused on looking for one specific number to match for parallel, one specific number, change the sign, flip your fraction for perpendicular. Any other number we get, the answer is neither. But in this case, we do have our slopes being 3/4, and then change our sign to a negative, flip the fraction to 4/3. And so these two lines are perpendicular, because those slopes end up being opposite reciprocals. So the answer in this one is perpendicular. The other type of question we went through on this, and what we focused on, was getting the equations of the lines. And we dealt with a form called point slope form. Which is y minus our y coordinate equals the slope times x minus our x coordinate. So I'm going to go through 28 so that we can just focus on the getting the equation of the line parts. And then we'll bring parallel and perpendicular back in here. So on 28, here's our point. And then here is our slope. And so if we're looking for our form here, that's our form. We have y minus our y coordinate, that's of our point. Our y coordinate here, here's x and here's y. Our y coordinate here is -5. So a -5 is what gets subtracted. Equals our slope. Well, our slope here is a -3. So our -3 gets attached outside there. Boom. Times x minus our x coordinate. Our x coordinate here is 3. And so now what we're going to do is we're going to get y by itself. So first off, y minus a -5, that's y plus 5, equals, and then we can distribute this -3. So we have -3 times x, and then we have a -3 times a -3 going across here. Negative times a negative is a positive. 3 times 3 is 9. And so all we need to do to solve for y and get y by itself is we need to subtract 5 to get rid of the adding. And so we get y equals -3x plus 4. Once y is by itself, then that is our end of the problem. Then we're done. And so this is going to be our process for the next couple problems. The only difference that we're going to look at is that we have our slope of the parallel lines being the same and the slope of perpendicular being the opposite reciprocals. Right? This is the key part that we're going to add. And then after that, that will give us our slope to put in our point slope form, and we'll solve for y like we just did. So let's take a look at how that looks in a couple of these examples. So we'll do number 30 next. Remember, opposite, change your sign, reciprocal, flip your fraction. That's what we're going to have. But we'll start with the parallel lines. We called it a new slope. Our new slope, since we want the line to be parallel, here's our slope. It's a -5. And we just want it to match. So our new slope is also going to be -5. So that's going to make things nice and easy for us because we don't have to do anything to the slope. We can just keep it the same. Y minus our y coordinate equals the slope times x minus the x coordinate. So now we're going to plug in. Here's our point. Here's x, here's y. Y minus the y coordinate, well, the y coordinate this time is 0, equals our slope, which stays the same, it's -5, times x minus our x coordinate. Our x coordinate this time is 1. Notice we're never going to do anything with this y-intercept, this -3 here at the end. The part that we want to take from this equation is the slope. The slope is what matters on those parallel and perpendicular lines. So we're going to go ahead and simplify that. We have y minus 0. Well, that's just y. So we don't even need to solve for y. It's already going to be by itself. So all we need to do is distribute. We have a -5 times x. And then -5 times -1 is a +5. And we're done. Let's look at one more, which is going to take a little bit more solving. So once again, we're going to get our new slope. This is the key part of this problem. The key part of these problems is getting this new slope. The new slope, well, the old slope was 2, and so the new slope, well, we want it to be parallel, so we want to keep it the same. Fantastic. Let's write out our point slope form. Remember, it is y minus our y coordinate. Our y coordinate goes next to y. Our x coordinate goes next to x. Slope goes here. So in this one, we have y minus our y coordinate. Here's our point. Our y coordinate here is a -5. Equals our slope, which is 2. Times x minus our x coordinate. Our x coordinate this time is a -4. So I'm going to go through this part a little bit more quickly because hopefully you're more comfortable with it. Minus a -5 is +5. And then we have 2x, and then this was a +4, so 2 times 4 is 8. And so all we need to do to get y by itself is subtract to get rid of the adding. And so we have y equals 2x plus 3. So remember that our new slope matched our old slope, and that is because those lines were parallel. If the lines are parallel, then you want to match it and keep the slope the same. So now let's look at some perpendicular ones. When they're perpendicular, this is when we want to change our slope and have them be opposite reciprocals. Change our sign, flip our fraction. So we actually need to do something for this new slope. Now that we're perpendicular, we actually need to change it, and we are going to have a brand new slope. So opposite, our old slope was a +2/5 here. And so for our new slope, we're going to change the sign. It was positive, now it's negative. And we're going to flip our fraction. So instead of 2/5, we're going to flip it and get 5/2. And that's going to be our new slope that we're going to put into the equation. So y minus our y coordinate this time is a 4, equals our slope, which is now -5/2. That's our new slope, that opposite reciprocal, times x minus our x coordinate. Our x coordinate here is -2. So from here, we just need to solve. And again, I'm going to go through this pretty quickly. We have y minus 4 equals, we've got -5/2 x. This is a plus, so a positive times a negative is going to be a minus. And then the 2's cancel, and we get 5. double 5 halves, we wind up back at 5. Doubling and cutting in half cancel each other out. And so all we need to do is add 4 to both sides to get y by itself. So we have negative 5 halves x minus 1. So again, the key part is getting this new slope being the opposite reciprocal. Change your sign, flip a fraction. So on 33, if you haven't already, pause for a second and think about what is our new slope going to be? And hopefully you figured out that change our sign, flip our fraction. Change our sign. The slope was a negative. Now it's going to be positive. Flip our fraction. So 1 over 5 is going to become 5 over 1, which is just 5. So our slope is now a positive 5. Change the sign, flip the fraction, because we're looking for perpendicular this time. So now we can make our point slope form. Y minus our y coordinate. Our y coordinate here is a negative 2. Equals our slope, which we decided was a positive 5. Times x minus our x coordinate. Our x coordinate this time is a negative 1. So again, try and work ahead of me here. Distribute and solve. Y minus the negative is plus 2 equals 5x. 5 times 1 is 5. And so all we need to do is subtract to get y by itself. Plus 3 is our answer here. So when we did this together in class, I wrote out, if you're looking for the video on it or the notes on it, it should be called equations of parallel and perpendicular. The slopes that we wrote out were, or the steps that we wrote out were, number 1, get our slope, get our new slope. Step number 2 was get that point slope form. So plug it into the y minus y coordinate equals the slope times x minus the x coordinate. Then just solve for y. But getting that new slope of parallel lines having the same slope perpendicular having opposite reciprocals, that's the key part of this one. So that is our parallel and perpendicular stuff. Know what they mean, know what symbols go with what, and know how to do questions like these. Now, let's move on to congruent triangles. As I'd already told you, there's no proof questions where you write out a long explanation of how the triangles are congruent. But there's still a lot of stuff that we need to make sure that we know. Mostly, you should know how to read a congruence statement. In other words, matching the pieces together. You should know all the different ways that we have to prove the triangle's congruent and how to tell them apart. And you should know transformations. So whether something is a translation, which is shifting, a rotation, which is turning, or a reflection, which is flipping. And you should be able to tell that by looking at the diagram. Those are kind of the main things that we talked about in the chapter before we started looking specifically at proofs. So those are the things and types of problems that we are going to look at here. All right. Are the triangles congruent? If so, state the congruence postulate or theorem that proves triangles congruent. So here we're looking at, are they side, 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 angle, side, and so on. So on this one, we're looking at some right angles. And once you see some right angles, you should think about hypotenuse leg coming into play. Right, because this isn't side angle side because the angle isn't the one that's included between these two sides. Here's my two sides. It's not this angle that's included. So it can't be side angle side. And it turns out this one is hypotenuse leg. Because if I'm looking, here's the hypotenuse, the side across from the right angle, that one's marked. And then we have one of the other sides that builds the right angle is my leg. On 35, I know that I have this common side here by the reflexive property. Don't forget about those. And this time, here's two sides. Here's the angle included between them. Here's two sides, and then the angle, it's not there. These are not congruent. These pieces aren't matching in the way that they should. Right? I would want this angle that's marked to be put down here if I wanted to make the triangles congruent. So there's an example of the triangles not being congruent. Oh, let's see. We have an angle marked here. We have an angle marked here. And we can also, hopefully you can spot that we have vertical angles. Here are the angles marked here. And so here's my three angles. So I'm going to go ahead and put angle, angle, angle. Oh, wait a minute. Angle, angle, angle wasn't on my list. That's not one of the ways we can make those triangles congruent, so this is not congruent. Because getting the three angles doesn't work. But, looking at the next one, getting the three sides does. Here's two sides. Here's the reflexive property. Common side in both triangles for the third side. So this one is side, side, side. And if we were thinking about transformations, this triangle flips to create this triangle. This would be a reflection. So you should know how to get those triangles congruent, those 5 different possibilities. You should know the difference between included side and included angle and something being not included in a side or angle. You should know the difference between those. It's a visual thing in the diagram. Now let's look at congruent statements. So congruent statements involve talking about which sides and angles match up with which. And so the thing to remember is that if I have, for example, if I write out the first triangle, ABC, here, I can choose an order for the first triangle. But once I choose an order for the first triangle, that choice is locked in, and I need to say something very specific for the second triangle. So triangle ABC is congruent to, we want to see what angles match up with what. Well, angle A in this diagram is going to match up with angle B, 1 tick mark with 1 tick mark. So A goes with B in the other triangle. Then we have B down here, 2 tick marks going with 2 tick marks up here, back to A. And then our 3 tick marks, our angle C, goes with 3 tick marks down here, angle V. So BAV is the way that those should look. By the way, this is a rotation, if you're keeping track of the transformations. And so take a minute to think about if I chose triangle DEF and asked you to fill in the blank here, what would we get? D lines up with T. E lines up with U. And F lines up right across from it with F. Next up, I'll only do a couple of these next groups of examples. Just to move things along here. The way that this works, just to remind you, state the new information not originally marked necessary to make the triangles congruent for the stated method. So we want angle, angle, side. So first off, what is already marked? What do I already have? Well, I've got these 2 angle Y's marked. That's a pair of angles. Cross that off. That's done. I also have this common side. Marked equal to itself. That's the reflexive property. And so I have this side done. And so the big thing I need is an angle. And so I need to choose which angle I want. Well, since I want angle, angle side, this is the key part of the question. Since I want angle, angle side, I want the angle that'll make the side not be included between the 2 angles. So let's see. That would be this angle would make it included. So that's the one I don't want. I want this angle so that I have my 2 angles and then my side that's not included between them. So the new information I want, the answer to this question is angle X congruent to angle D. Because once I know this, I have angle, angle, side. So the question is basically asking, I know 2 things are equal. I know 2 pieces of information that are matching. Give me the 3rd piece of information. So let's look at one more of these, just so that you see that. Hypotenuse leg. We talked about for hypotenuse leg, we need hypotenuse, we need a leg, and we need a right triangle. So let's see what we already have. Well, here's some right angles. That looks like a right triangle to me. So we got that so far. We have this pair of sides that are marked. That's a pair of sides. Is that a hypotenuse or a leg? Well, it's one of the sides that are creating the right angle. And so that means it's a leg. So I have my leg. I've got a right triangle. What I need is a hypotenuse. And so where's the hypotenuse? For the hypotenuse, I look across from the right angle. And that's my side. So I want M to L to match up to, look across from the right angle, and I see C to D. This is my answer. I had the right triangle, I had the leg, I needed the hypotenuse. That's the last information that I needed. Got 2 things, I need the 3rd.
And so that comes down to understanding and knowing those congruent statements.
All right, couple more things to practice with congruent triangles. We're almost done here. So this is making sure that we know how to do the congruent statements. Complete each congruent statement by naming the corresponding angle or side. And so this involves making sure we understand what the statement tells us so that we can match up our pieces of information. So first of all, we have the congruent statement. We have IJK and DEC marked congruent. And so for these problems, I almost don't like to look at the diagram. I just like to look at the congruent statement up here. Because if I want K to I, if I want to know what K to I should match up with, then if I look at the congruent statement, Ki is last then first. And so I wanted to match up with the same thing over here. I wanted to match up with last then first. C then D. So in other words, K to I should match up with C to D. But I'm focused on this congruent statement. And finally, let's look at one of those with an angle. Just so that you see how that looks. So here's the congruent statement. KJL is congruent to JKW. So we have LKJ. We want LKJ to match up with, this is, in order, LKJ is, in the congruent statement, is 3, then 1, then 2. It was 3, then 1, then 2, LKJ. And so we wanted to match up with 3, then 1, then 2. So in other words, angle LKJ should match up with L should go with W, then 1, K should go with J, then 2. And that applies to measurements too. If I knew angle W and asked you for angle L, well, angle W should match up with angle L. And so that gives you the piece of information to associate with it. So if you're given something like that, look at the congruent statement, if you're given one, and match up, okay, which side goes with what, which angle goes with what. So congruent statements, all of our different ways to prove the triangle's congruent. So side, 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 angle, side, all those. And knowing transformations, translation, rotation, and reflection. That's the stuff we're going to ask you with congruent triangles. The stuff we're going to ask, the other questions are going to be about the parallel and perpendicular stuff we talked about at the beginning. So hopefully that should get you all set for the type of questions that we're going to see for the final exam. And if you have any questions, feel free to send me a message and let me know. But that's all I have for you for now. Thanks for watching, and I will see you next week. Have a good weekend.